Okay, let's see the solution of test number 727. The question is, a current I is passing along straight Y. A circular Y is moving toward the straight Y as shown in the figure. What is the direction of induced current in the circular Y? Okay. To answer this, we have to understand the process of how the induced current, how can we get the induced current in the circular Y. Okay. First, when you pass the current into this long straight Y, it will produce the magnetic field. Okay. And we can calculate it easily using the Ampere's law. You can use both the Biot-Savart or Ampere's law, but it's simpler to use the Ampere's law. That is, we know that at the distance r from the Y, we have that the integral of b dot ds is equal to mu 0 I. Okay, ds is a displacement vector. I is a current, D is a magnetic field, and ds follow the right hand rule. If your thumb point in the direction of I and you curl your forefinger, ds will point in the direction of your forefinger, that is ds. And we have discussed this many times, that this system has a symmetry, and we have that B is parallel to ds and B is constant on this closed loop that had a center at the Y. Okay, so we must have that B of integral ds is equal to B times 2 pi r, which is equal to mu 0 I, or we have that B is equal to mu 0 I over 2 pi r. Okay. The point of discuss this expression is that you can see that B is inversely proportional to R. It means that if I is large, B will be small, and if I is small, B is large. So when you come closer to this Y, you will have the larger or the stronger magnetic field. Okay, so this is the first thing to know. Now, the second thing is that we have a circular Y here, and this circular Y moves toward the straight Y, and the magnetic field that produced by the straight Y will pass through the circular Y, and it points into the plane like this. This is the magnetic form, the straight Y, and when the circular Y move closer to the straight Y, it means that the magnetic field will increase. Right? The magnetic field that passing to the circular Y will increase, and which means it will increase the flux, magnetic flux that passing to the circular Y. And from the Faraday's law and Lenz's law, we know that from the Faraday law that when the flux of the magnetic field that passing to this circular Y change, it will induce the electromotive force, and that will induce the current to move through the circular Y. And the direction of the current can be determined from the Lenz's law, that this current will produce the induced magnetic field that against the change of the magnetic flux. You can see that when the circular Y moves closer to the straight Y, the flux will increase, and the magnetic field point into the plane like this. So to cancel this magnetic field B, this blue magnetic field, the induced current will produce an induced magnetic field, this red magnetic field that point into the opposite direction to the magnetic field, the blue one that comes from the straight Y. So we know that the induced magnetic field will point out of the plane like this. And to produce this magnetic field, you can use the right hand rule. By point your thumb in the direction of the induced current, and then when you curl your finger inside the Y, the direction of your forefinger is the direction of the magnetic field. So you can see that if the induced current point in this direction, the magnetic field inside the Y will point out of the plane. So we have the answer to this question, that the induced current must flow in the counterclockwise direction, right? In this direction, which is counterclockwise, to produce this induced magnetic field against the increase of the magnetic flux to the circular Y. So the answer is the choice number 2.